Well, hi there, everyone, and welcome to this Ed Events community live stream where today we have our special guest, Ryan Tannenbaum. G'day, Ryan.
Hi, David. Nice to see you. And hi, everybody here.
It's great to see you, and we can see people just joining us from various platforms where they're watching. If you'd like to drop a comment and just say hello and let us know where you're joining us from, that would be really great. We can see got a few comments there from David Miles. Great to see that he's tuning in. And yeah, looking forward to this presentation. So Ryan, what are you sharing with us today?
So, if you're here, you've probably seen me around on one of the various platforms. I post a lot about a lot of different things around AI, but I find it's often easier to grasp when you hear it, and we can have a bit of a conversation too. So please, at any point, leave comments. We'll surface them up. If you have any questions, it should be interactive. At the end of the session, we'll have a little bit of a Q&A, and then we'll have a breakout if anyone's interested in chatting and going a bit deeper. Today, we're going to be looking at some AI fundamentals. Hey, Anthony, really nice to have you join us. We're going to be building on this idea that if we want to effectively use AI, especially in education and in schools, we need to understand it and be able to ask the right questions about it. So we're going to look at how some of these systems work in a very non-technical, beginner-friendly way. I actually tested this with my 7-year-old father, who has no idea about AI, to see if it was accessible and interesting. And he, found it really enlightening. I'm not comparing anyone here to my 7-year-old father, but don't be intimidated. It won't be like some of the heavier stuff that this can get into.
Well, and it's good to see we've got quite a few viewers joining us. So I think now might be a good time to get started. So Ryan, I'm going to get out of the way and hand over to you. Take it away.
Okay, great. Well, hi, everybody. So I'm Ryan. You probably know who I am if you're here, but I worked in international schools for quite a while, about a decade. I then started a consultancy about 4 years ago. It's called For Education. That's our website, also for.education. But if you want to, get in touch or reach out, just hit me up on LinkedIn. Probably the best place to find me. So today we're going to be looking at implementing good AI in our schools and in our processes. And what does it mean to implement good AI? Well, it means that we understand AI. So what are we going to talk about today? We're going to talk about tokens. And I talk a lot about tokens. I'm the more I learn about them, the more fascinated I get. And I could probably go on for hours and hours and hours about why they're so interesting. Today will only be 30 minutes, and we're going to actually really learn a lot about how tokens work. And by understanding that, we're going to also start to understand, well, how do LLMs, how do large language models like ChatGPT and Claude and Llama and any of these other guys, how do they work as well? So finally, we're going to do some experimenting, and I'm going to share something that I've shared on LinkedIn. And a lot of you might have seen, but I'm going to share it again here. So if you want to do your own experimenting and exploring, you can feel free to. But first, we got to talk about what are tokens? And so GPT-4o, which is the latest big model, also the O1 models, if you know what those are, but basically all the latest ChatGPT models have a vocabulary of 200,000 tokens. And so what does that mean? Well, they don't really know words, they don't really know letters, they don't really know any language. They have a list of 200,000 tokens, and that's what they know. And so sometimes they do really weird and silly things. Like something I posted about was this, where I have a paragraph with no letter E in it. And I say, does it contain the letter E? And it says, yeah, especially the words through and shadows, which don't contain the letter E. But it doesn't know that because it doesn't actually see the letters. It sees the token. For it, it's just an item in a row on a shelf. And it's oh, that one I think has an E in it. It can't look inside of it. It's just an index for it. It's just a token. Basically, it doesn't know letters. When we see letters, it's a little computer program that changes the tokens into letters. So how do these LLMs work, or what do tokens look like? How do the LLMs work? Well, here's a sentence. So if I type that sentence in, first there's a little computer program called a tokenizer that's going to chop it up into these different parts called tokens. And it's going to give the tokens to the AI. It's not going to give my words to the AI, it's going to give the tokens. And if we look at this sentence, it's not a very exciting sentence, but it does showcase what I'm trying to say. Almost every word has its own token. So R is its own token. My very favorite food, all their own tokens. Hey, James. Yeah, nice to have you here. And so common words generally have their own tokens because they are so common that it makes sense to just pass them, and then the model can get like a really clear idea of what this word means. But less common words like pineapple, not as common. It's actually broken down into 4 different tokens. So the big takeaway is that tokens are generally like words or parts of a word. The most common words have their own tokens. Less common words can be made up of many tokens. You know, something that's interesting to me, maybe it's interesting to you as well, is that the internet is predominantly English. Like, that's not news to anybody, but it means that because these models are trained on the internet, most of the words that they've seen are English words. So words in other languages are generally made up of more tokens because they're less common in what these things are trained off of. So what does that mean? What's the importance? Well, for one thing, it means that these systems are much more expensive to use if you are speaking another language. Like Korean, I think, can be up to 3 times more expensive than English. Portuguese can be about 50% more expensive than English. Thank you to some commenters on LinkedIn who also pointed that out about Portuguese and some of the other languages. Basically, the more tokens you use, the more you pay to use the model, the more energy it uses, which means like there is kind of a linguistic bias with how these systems work. But to get back on track, we're going to talk about, well, what do these models do? Because it's really important. If we're going to understand how they work, we need to understand what do they do. So what do they do? Well, they have one really simple job. And all that job is to choose the next token. So here's what Ryan said. Ryan said, are there any letter E's in this paragraph? All it's going to do is say, what is the next thing I should say? It's not planning a sentence. It's not planning a response. It's not reviewing. It's just saying, given this, what's the word that should come next, or the token that should come next? And what that means is that it's just going to do that many, many times to make a sentence. So it says, oh, okay, let's say it's going to say this sentence has the letter E in it. First, it's going to say this, then it's going to take my question again, the little sentence with no letter E in it. It's going to take its response that says this. It's going to go back through the AI model. It's going to choose another token. And it just keeps doing this again and again and again. So how it does it, what happens in the middle is kind of complicated, but what it's actually doing is pretty simple. It's only choosing one token at a time and predicting them as it goes. And so how do they pick a token? Well, actually, it's kind of weird, but they don't. What they do is they look at all 200,000 tokens in their vocabulary. It's gigantic. And they say how likely each token would be. So, you know, hi, hey, how are you? Saying, oh, I'm fine. Like, that's probably pretty likely. Saying something in Korean is probably much less likely. It's going to be like a 0% because I spoke to it in English. But it's still going to, for every single Korean and English and Chinese and Bangladeshi character in its vocabulary, it goes through all of them and assigns a probability, which is one of the reasons why they're so, you know, energy intensive. But basically, once it's assigned that probability to every token, then, you know, it knows how likely it should choose each one. And a high score means that it should probably come next. And a low score means probably shouldn't come next. So we can get a really good example of this if we say, like, name a random country. And so I built a little program that can show me the probabilities of these tokens. So like the word Mongolia, like that's the random country it comes up with. But if we look, it's 3 different colors. The purple means that that M was actually pretty unlikely to show up. It was 35% chance that it was going to choose an M. Could have chose, like the next one was Kaz, 10% chance. That's Kazakhstan. Next one's T, like maybe Tanzania. It wasn't that likely. It could have gone in a lot of different directions. But when it's choosing the next one, this Ong, we can see it's in green. What does that mean? Well, it means it's 98% likely to choose Ong. You know, it's already chosen M. So if we look at like kind of the top 4 here, for some reason, it really likes Mongolia more than Mali or Moldova or Macedonia. But like those are all kind of M countries. We can see that the probability is much stronger. It's not like going much more in a certain direction. And then the last one is blue because there's 100% chance. Once it said Mong, it's going to say Olia. There's no other country it could have been. So the way the system that I built works is that if I say something like, what's a great restaurant in Busan? I live in Busan. Doesn't really matter what it says, but it comes back with like this huge rainbow of different tokens, you know, and their probabilities. And so the way this system that we're going to jump into in a second works is it basically says if it's blue, pretty much guaranteed that that is what it's going to pick. If it's green, it's pretty sure. So I think it's more than 95% probable. If it's yellow, it's more than 70% probable. So it's quite likely. If it's red, it's like 50% or more. So a little bit more shifty. And then purple is less than 50%. So what does this mean? Well, it means that like when we're interacting with the models, we can see what's it telling us. So sometimes the models are pretty honest. So if I say, tell me a random number, then it's going to say 47. And you can see like there was a good chance it would have been a different number here. It said 47, but like there's a good chance it could have been something else. It's relatively random. I wouldn't say this is like a true random assortment, but there is some randomness here. I think this is interesting because it does highlight one of the ways that these systems are really different from, you know, other things in that like this isn't random. I mean, 47 has an almost 50% chance of coming up here, but there is some variability in the response. And I think that's important to understand that it's not necessarily doing what you think it's doing. Because if I went to like ChatGPT and I said, tell me a random number, no tools. And the reason why I say no tools is because I don't want it to, you know, open up Python. You know, if I say do it again with tools, see if it listens to me. But yeah, it'll like open up Python and it'll actually, you know, use a computer program to try and generate a random number. But when we're just asking the AI to do something, not using external support, it like this 42, is it random? Well, no, it was the second most probable thing in our list over here. You know, if we got a number other than like these top 5 numbers, it would be really, really unusual. To drill out like even further, we can say, tell me a random number from 1 to 10. Now run it again, we get the answer 7. And this, like, you're only going to get a 7. With ChatGPT, a random number from 1 to 10 is not random. It's always going to be 7. You know, again, we can go here and say no tools so that it doesn't open up Python, and we get 7 because ChatGPT will always give me 7. And so this is what one of the things we need to talk about when we're talking about real AI literacy is that random doesn't mean random with these systems. There's probabilities that come up, and we need to understand those probabilities if we want to kind of understand a little bit more about the output. So another interesting example that I like to give is about hallucinations. This doesn't work all the time, but I can give you a really good example of how we can use these probabilities to see hallucinations in these models. And basically, what's a hallucination? That means that the model has said something like it's true, but it's not true. So one of the most common errors, or one of the most famous errors that these systems have, is something called the reversibility curse. And so I'll show you what that is. We can say, who was Philip Seymour Hoffman's mother? And it will tell me that it was Marilyn O'Connor. We're really going to focus on this first part. You can see it's all blue and green, which means it's really, really certain that that's the right answer. But if we say, who was Marilyn O'Connor's son, we're going to notice two things. Number one, well, let's see. Maybe it'll answer. These things give us different answers every single time. Okay, so we'll notice two things here. Number one, it didn't tell us that it was Philip Seymour Hoffman. And that is the right answer. It told us it was somebody named John O'Connor. But number two, this isn't just blue and green. There's a lot of different colors here. And so kind of the source of where is this thing going to hallucinate? Well, it's probably going to be on the name. So if I click there and it says John, but it could have been Chris or James or Jerry or Jim or Michael or George or Pat or Mike or Brian or Conan, or even Ryan down there. It is relatively certain that it is John, but it's only like a coin flip. Maybe it's John or maybe it's any number of other things. We know that this is wrong. But that's one way that when we look at these probabilities, we could say, well, is this true or not? And I think this gets really, really interesting when we talk about different ways that we can use AI systems and kind of really, again, developing that little bit deeper literacy. So one thing to understand about how these systems work is that they are pattern matching systems. They really feed off of patterns that exist, and they try to replicate those patterns in data. And so one interesting way, I think, to recreate this, and it's a way that even in our human processes, we will do something similar, but I can say something like this, write me a rubric from 1 to 4 for a middle school language class. And so it's going to take a little bit longer because this is a bigger job, and the way I'm working with it, and we're deconstructing the tokens, we wait for everything to come out. So I'm going to do this a little bit differently, just so this is kind of hard to read because it's given it to us in markdown format. But to return it as a list and have, let's say, 3 categories that are assessed. Something like this. And the reason why I'm doing this is because what's going to end up happening is that you will see for the first, so here we've got some responses. Here are the categories assessed. There's a lot of uncertainty here in how it's defining things. When we get to number 1 over here, we've got a lot of red and purple. But when we get to number 2, there's quite a bit more blue. When we get to number 3, there's a lot more blue. You can see in these types of words, it's already learned this pattern from what came before it. This isn't really an effective way to build a rubric, but it does show this progression where it gets more and more and more certain as it moves forward. So why did I introduce that? Well, if you're using these systems to generate rubrics and things like that for yourself, it's really important that you're giving it examples, because it's going to learn from your examples and really try to mimic that behavior that you have demonstrated. And so a lot of times when we look at time-saving potential, when we use AI systems, what we really want to consider is, well, how do we get good output? We don't want crap. We want good output from these systems to save us time so that we can focus on what's more important. And so how do we do that? Well, we need to demonstrate what good is, and I think that's a fundamental thing with a lot of things in life. So I have a slightly alternative version of this platform that lets us also, pre-populate with some data. So the other thing that I think is really important for us to explore and develop an understanding around is around what these systems are really, really bad at. And so I think it's really crucial that educators understand that these systems are not well suited for quantitative assessment. So what that means is they shouldn't be giving students a grade. And I will show you why. Um, but first, I would ask you to ask yourself a question. If you were in a leadership position and you were hiring a teacher to do your grading, well, they're a teacher, so they're going to do grading. You're hiring a teacher, but you know that they mark boys and girls differently, or you know that they are biased towards certain types of writing styles, or you know that they are just radically inconsistent when it comes to grading and marking. Would those be things that you think, well, I'm really excited to get this person to do assessment? You know, if that was a known fact for you. I would assume no. But with these AI systems, it can very much be that they are not going to assess accurately. And so I'm going to do a demonstration of that by clicking on MYP rubric. And what this does is it just brings in an MYP rubric for me. It's a writing rubric for middle school and language. And so if you don't know the IB, it's just this is what a level 0 is. This is what a level 1 to 2 is. This is what a level 3 to 4 is, 5 to 6, 7 to 8. So we have that. And if I click essay, I have an essay written by Claude. Not a great essay. I asked it for a fairly mediocre essay. So if I'm going to say something like, return a grade from 1 to 8, return just the grade, I click generate response, I get a 5. I get a 5 with a 73% probability. I get a 4 with a 21% probability. And so it's only like a grade scale from like 1 to 8. It's a pretty big difference. However, I'm going to dramatically change this, just upend the whole thing. And I'm going to delete that part, and I'm going to say return only a grade from 1 to 8. And I'm going to run it again. And now I get a 4. And there was like a chance it could have said grade or something. If I put in some like more white space over here, maybe some other spaces, I'm getting a 4 with even less probability. Down here, like we can even see like a 6. Earlier when I was doing this, like I was getting 3 to 4s. But my point is, all I've done is I've changed like 3 or 4 words in the prompt, and it's shifted the student's grade fairly substantially from, you know, a whole grade point down. And so if you're implementing a platform that is doing assessment for your students, how do you know that their prompt is not unfairly altering the student's grade? If we went like up here and we change it to GPT 4.0 instead of 4.0 mini, and we run it again, we get a level 3 with, you know, 63% probability. What does that mean? Well, what does it mean for your student if they were using GPT 4.0 mini because it was cheaper and they typed only there, then they would have gotten a 5. If they were using GPT 4.0 because they thought it was more accurate, then they got a 3. But all of this is, you know, relatively arbitrary. And these are questions that I think we really need to be asking of the platforms that we bring into our school. If we switch back to, you know, another model, so the first model, and we just flip it around. So we do the essay first, and then we do the rubric, and we say, return only a grade. We'll get a totally different grade. You know, now we got a 5 again with like fairly strong probability, which is interesting. I think under the grade one, like actually the most likely grade was a 6. So, you know, it's kind of really, I think, important that educators understand this when they are looking at how they are implementing these systems, because if you're not looking at this side of how they work, then okay, it's a 5, great. cool. I don't need to mark that essay. Or oh, it's a 3 because I used GPT-4o, and I had that specific prompt structure. Great, but is that reliable? Is that something you can really build off of? I don't personally think so, and I hope that that's one of the takeaways that people take from this. So I've been talking for 25 minutes now. It's probably longer than I need to be. So if people do have questions or comments, please leave a message. Uh, it's always great to get kind of live feedback and start to have a discussion.
And of course, if people are watching this later on, they can comment regardless of what platform you're on, and the conversation can continue beyond as well. Ryan, at the moment, I'm in Hong Kong and I'm going to the Learning and Teaching Expo, checking out a few things tomorrow. If I go and talk to somebody who has an AI product, what are some of the how can I sort of summarize what you're talking about here? How can I sort of get straight to the root of how effective is their product and how it all works?
Well, so one thing that probably unites most of the people here who are watching us is not that we are, obsessed with AI. It's that we're educators. And so don't look at these systems as this new and complicated technology project or product. Evaluate them like something you would do if you were bringing a new staff member into your school. And so if the product offers assessment, then against what standards do you assess? How do you normalize your standard or your assessments? How do you ensure confidence in the assessments that you are giving? Just like when you're interviewing a teacher, okay, so you mark English. When you're marking an essay and when you're looking at student work, what features are you looking at in order to assess students and facilitate their growth? What are your strategies around formative and summative assessment? So if they're not doing quantitative assessment, the first part of that question is still valid. You want me to buy your platform, it's going to cost me $10,000, $20,000, $30,000 to bring this into my school. So how are you going to ensure that it's helping to meet students' learning outcomes? I've seen a lot of AI systems that offer personalized tutoring and offer dedicated support for students, etc. But how do they help me as a teacher or me as an administrator or help my teachers monitor student progress and growth and know where they are against the benchmarks that we've set in our curriculum?
So we've got a question from Jamie, and he just says, hi there. Comment, actually. There we go. It says, I think that this is something that all educationalists should see. Can this session be shared with others? Absolutely.
Yeah.
Too easy. Yeah. The link that you're looking at right now, it'll just stay live.
Yeah. So once we're done, it'll be there, and just feel free to share the link with anyone. I really hope that people take this seriously, because I'm actually a pretty big fan of this technology, but I do worry that we're basically running a social experiment with our students. And there's evidence right now that we could know a lot better.
Anthony says, dude, thanks for the insight. One way to get more reliable output is to convert natural language to a code interpreter for math problems. Thoughts?
Yeah, I mean, so in math, when you have a question and you have an answer, then sure, that can work. I think with language, it becomes quite a bit more subjective. So it would be more difficult. But also, even with math, it's like, what are you looking to assess? Are you looking to assess merely the correctness of a response? Then, when I was in high school, we had Scantron sheets, and those worked pretty well. We don't, and optical recognition, is this, you just put your answers in, and then I don't even know if you need AI for a lot of that. But, one of the things that we were exploring, or I was posting about on LinkedIn earlier this week, was that ChatGPT, earlier this week, it did this. It wasn't doing it yesterday night when I was trying to demo it, but you could say, what's bigger, 3.11 or 3.9? And it would say 3.11 is bigger because 11 is bigger than 9. It's not, 3.9 is bigger because that's how decimals work. But it wasn't able to get that right. And so, especially with math, there are fundamental issues. That's not what Anthony's asking. He is asking, like, if we use a code interpreter, then we'll be able to do better. I generally spend all my day inside like an IDE programming. And I will say after 2 years of GitHub Copilot, like I rarely use it now to write code because of the amount of hours and days it has cost me, because it has made like really subtle errors that I then need to go and find and pick up later. And so I would be quite cautious implementing it in any type of high stakes environment. That's not to say it's useless. Like I use it all the time to talk to me about really complicated math things. Like I'm trying to read a lot more AI papers lately, and they come with very, very complex mathematical equations. Like, this is the equation for a sparse autoencoder and blah, blah, blah. And, I can take a picture of that and I can say, look, talk me through it. And let's go through it like really carefully. And then, I can gauge my understanding, and I can be like, look, what you said didn't really make sense. Are you right about this? And that is a really effective way to learn, where you're kind of probing back and forward. And they are kind of good at that direction. But using it for assessment, especially automated assessment without oversight, is, I think, what happens to the kid who it gets it wrong for and they get a 3 instead of a 7 on an assignment, or a 3 instead of a 6 because the prompt was slightly different, or it misconstrued something. I don't think it's a one and done deal. It was a very long-winded answer, but I don't think it's well suited for really any type of high stakes endeavor.
And of course, that's math. What about maths? I mean, it's a totally different thing when you put that S on the end. No, sorry, I'm just being silly.
Well, maybe, who knows? We should do an experiment about
that. Would be interesting.
Yeah.
So look, I think it's been really interesting, and obviously we've had a few people mentioning that they want to share this video. I think it's quite clear what you're talking about here is just the need for, and James is backing me up there on that one too. He says +1 for maths. I think obviously we're looking at a future where we really need to understand what any solution provider with AI is, how they're operating, and that can only be good if we can clearly understand how things are working. Then we can sort of make an informed judgment, as you say, just as you would if you had a staff member coming in and doing assessment with students. I think we might sort of wrap it up shortly, but just before we go, first of all, thanks very much, Ryan, for this presentation today. And that's what the EdEvents community is for, to put the spotlight on all sorts of things and great ideas that are happening in the education community. If you're not a member of the EdEvents community, please do join. It's free. We've got over 1,000 people now have joined as members on the EdEvents community, which is very exciting. And we hope to see that continue to grow. You can go onto EdEvents and find all sorts of workshops and conferences and webinars and all sorts of things in one convenient place. So working in international schools means that you're connected to an international community. So ed.events is the website. And Ryan, for education, for.education. We've got some consistency in our URLs, which is very nice. But thanks very much again, Ryan, and thank you to everyone. And I guess it's also worth pointing out that for a lot of people out there, this is probably the second last day of the school semester, or maybe even the year, depending on what part of the world you're in. So hopefully everyone has a really nice day tomorrow and has a really nice Christmas, New Year / holiday break. And yes, so thanks very much for taking the time to watch this live stream. Thank you, Ryan, and hope everyone has a great afternoon or evening.
Yes, thanks a lot. And if you want to connect with me, please feel free to direct message me on LinkedIn. But hope to hear more from you in the future. And I really love to engage in this conversation, so don't be shy to reach out.
Fantastic. Thanks again, and see you next time.
Bye-bye.